lesson 8.2, graphing quadratics of the form f of x equals ax squared plus c, you should be on page 426. In this lesson, you will learn how to graph a quadratic function of the form I just mentioned, and then how to solve real-life problems involving functions of the form I just mentioned. Now, when you graph these, you'll notice in the last lesson you learned how to graph functions in this form. So the only difference in today's lesson is we're going to cover what is happening when we take a function like this and add or subtract some number to it. And they talk about it right here. If the value for c is positive, in other words, if we're adding something, it's going to vertically translate the graph that many units up. So it's going to take our parent function and push it up the y-axis. On the other hand, and maybe I should just say that again, this is just saying that when you add something, it means move the graph up that many units. And then if c is less than 0, in other words, if you're subtracting something, that's how many units down it will move the graph or the parent function. Okay, it's moving that many units down. Now when you translate your graph, it's going to change your vertex. So this is just saying the new vertex. So if c was 3, for example, it would take my graph and move it 3 units up the y-axis, which means my new vertex would be 0, 3. That's what this is trying to articulate to us. So let's talk about how we graph these. Let's graph this. So the graphing part should be easy. I want to discuss the comparing it to the parent function more. But let's just talk about the graphing. You can do this on your calculator. So let's get our calculator out. And let's go ahead and type in both equations. So y equals key. Let's do the parent function. And then the function that we were supposed to graph was g of x equals x squared minus 2. Okay, so let's take a look at the graph first. I'm just going to hit graph. And you'll notice here, okay, so you'll notice, let me freeze my screen, and I'm going to try to trace using colored pencils here. Okay, the parent function is right here, it's in blue. And the actual function g of x I'll try to trace in black. And you notice how the parent function is 2 units lower. Its vertex is at 0, -2. Now, how could I have known that by looking at the equations? Well, here was the parent function, and here's the function g of x. The -2 that I'm highlighting told me that this function should move down 2 units, which is what it did. It just moved it down 2. Okay? Now, we can make a table. Now, to get this on graph paper, you can go to your calculator, make a table, and let me try to color code this. Here are the y values for the parent function. So if I want to graph the parent function, there are my y values. Now, if I want to graph the function g of x equals x squared minus 2, the y values for that are here. So now I can just take this and plot these ordered pairs and graph both functions. Now I know you see a little picture of that here still. When I graph the ordered pairs in orange, like 0, -2, that's going to be here, or 1, -1. 1 right down, 1 down would be there, and so on. And then there's the parent function. So I should be able to use my calculator to help me graph them both. So the graphing part should be easy. Just put this in your calculator, put the parent function in your calculator, put them both on paper. Now, what I'm worried about is the comparing. Let's talk about the comparing. Okay? We talked about how this is taking the parent function, that -2, and it's moving it down 2 units. Okay? When we compare, we're going to write 2 sentences. We're going to explain how the vertex compares on both and how they open. So, remember, when we're adding outside the function, that's a vertical translation, but if it's inside, that would be horizontal. You'll find out in this lesson, we're focusing on adding or subtracting outside. So these are going to be vertical translations. Okay? So let's compare the vertex. Okay? The vertex of the graph of g is 0, -2, while the parent function has a vertex of 0, 0. Okay? So I just compared the vertex in this sentence that I'm highlighting in orange. The vertex of the function g of x is 0, -2, while the parent function is 0, 0. Now let's compare how they open. I'll do that in the light blue here. They both open the same. Okay, they're both the exact same graph. They both open the same. Do you notice the number in front here would be 1 and the number in front here would be 1? They both open the same. Okay? The only difference is their vertex has changed. What I would like you to do is, they ask you to graph. I crossed that out. I don't want you to graph these now. You'll practice, using your calculator and putting them on paper in the homework. But what I would like you to do is look at each of these. Can you compare the parent function with each of these graphs by just looking at what was being added or subtracted? Go ahead, stop the video and try that. Write down the comparison. Okay, and we're back. And so for number 1, g of x would be translated 5 units down compared to the parent function. Its vertex here would be 0, -5. But it opens the same. How do I know that it opens the same? Well, look at the number in front of x squared. A is 1 over here. A is 1. They open the same, but the -5 translates this down 5 units. In question 2, h of x would be translated 3 units up compared to f of x. Its vertex is 0, 3. How do I know that? Well, right here, look at, we're adding 3 to the parent function. It's moving it up 3. However, they open the same. How do I know? Because in both the parent function and h of x, the a value is 1. So they're going to look the same, it's just this is moved up 3 units. So we ought to be able to look at the function and without even graphing it, be able to compare it in sentences. Let's do another one here. They want us to graph g of x equals 4x squared plus 1 and then compare it. So the graphing part I think I'm going to skip over because you could take the graph, you could type in this function and the parent function in your calculator just like we did in the previous example, make a table and get those on paper. What I want to focus on is how do they compare. Okay, how do these two things compare? Okay, let's start here. We're adding 1 to g of x. Well, adding 1 is going to translate this 1 unit up and give the vertex of this, it's going to make the vertex 0, 1. So let me highlight that, okay, so you can see that here. The vertex is 0, 1. Okay, it's been translated 1 unit up. That's what the plus 1 tells me. Okay, now here's the next thing. I want you to notice here, it says a is 4. But on the parent function, a is 1. This is 4 times greater than that. So this is going to stretch the graph. It's going to rise more rapidly than the parent function since a is 4. So it's going to stretch the graph by a factor of 4. So let's point that out here. Okay? So you can see that. This graph is narrower because it's being stretched. It's being stretched by a factor of 4. You can see that in the wording. Okay, so without even graphing it, I ought to be able to look at these things and determine how do they compare. I would say I would hit this pretty hard in multiple choice on the chapter test. I would be like, okay, here's a graph, here's the parent function. Tell me which sentence properly compares the two. Let's look at translating these type of graphs. So here they say f of x is -0.5 x squared plus 2, and g of x is equal to f of x minus 7. So, okay, what does this mean? This means this graph is taking the graph of f of x, which is here, and it moves it down 7. Okay, it's moving this graph down 7. Okay, so now to graph it, it'd be easy to graph, I could type this in my calculator, and I could plot the points and make the graph. You can see they did that here. And then look at what they did here. They just took all the all the y values I meant to say, and they moved them down 7. And then I could graph the second graph. So they're going to look the same, it's just this is moved down 7. They want me to now write an equation for g in terms of x. So if I want to write an equation for g in terms of x, okay, and I put a little note here, I should have added this earlier. I'm just telling you the minus 7 is moving the graph down 7. Let's talk about writing our equation now, okay? G of x is to take f of x and subtract 7. So here's f of x. Let me write it out. It's negative 0.5x squared plus 2. And I'm supposed to take away 7 from that. Well, 2 minus 7 is negative 5. So g of x would be this equation then. Okay? There would be the equation for g of x. And you can see that here. All right? So that's how we can do a transformation from one function to another, and then writing an equation for that second function in terms of x. Again, for these next 3 sample questions, I'm going to cross out the graphing part. You're going to be able to plug these in your calculator and graph them on paper. That's easy. I want to worry about the comparing part. I want you to write sentences. Now remember, compare the vertex and how they open for numbers 3 and 4. And then in 5, again, I'm going to cross out the graphing part. I want you to describe the transformation from f to g, and then write an equation for g in terms of x. Pause the video and go ahead and do those 3. Okay, you had a chance to do that. And for number 3, this graph is stretched by a factor of 2 compared to f of x. Let me highlight why. Because I see a times 2 in front where the parent function would have a 1. And then here's the next thing. It is also translated down 5 units and has a vertex of 0, negative 5, while f of x has the vertex of 0, 0. How do I know that? It says minus 5 here. Okay, let's go to number 4. It says this graph is reflected and shrunk by a factor of a quarter compared to the parent function. How do I know that? Well, look at, there's a negative 1/4 in front. Negative reflects and quarter shrinks. The parent function has a 1 in front. Okay? Second thing, this is translated 4 units up from the parent function and has a vertex of 0, 4. Well, how would I know that? Well, look at the equation. It says plus 4 here. It's adding 4 to the parent function. It's moving it up 4. Okay? And then in question 5, let f of x equals negative 3x squared minus 1 and g of x equal f of x plus 3. Describe the transformation. Well, you see the plus 3 here. That's going to take f of x and translate it 3 units up. So g of x is taking f of x and moving it up 3 units. Okay? Let's write an equation for g in terms of x. Well, maybe I should do that here. Okay, so g of x is taking f of x, which is 3x squared minus 1, and adding 3 to it. Well, if I combine these 2 things together, that's positive 2. That's why there's my answer. Writing g in terms of x, g of x would be 3x squared plus 2. Okay, and then to wrap the video up, we would use these techniques to solve real-life problems. Now, a 0 of a function, f, is an x value in which f of x equals 0. So that sounds kind of complicated. It's easy. The 0 of a function is the value for x, which makes y equal 0. So really, this is one part that I do get frustrated with algebra. You probably do too. This is another definition now. So there's really 3 definitions for this situation. X could be called a solution. It also could be called a root. Now it's being called a 0 of a function. So when you plug in a value for x that makes the whole statement work out to 0, that's also called the 0 of a function. So I know that can be frustrating, but you need to recognize that these 3 things are telling you the same thing. I could ask you to find the solution, or find the root, or find the 0 of the function. All 3 of those are asking the same thing of you. Okay? The zero of the function is the x-intercept of the graph. Think about that. When y equals 0, that means we are on the x-axis, which I'm highlighting. So we can use that information to solve a real-life problem. This function represents the approximate height of a falling object t seconds after it's dropped from the initial height in feet, which is s. An egg is dropped from a height of 64 feet. After how many seconds does the egg hit the ground? So if it's dropped from a height of 64 feet, that means s is 64. So I'm going to put that in my equation. Okay? Now I need to solve this. So there's a couple ways I can solve it. I could factor it. I could make a graph and table. So the book is taking this, putting it in their calculator, making graph and table. So we'll do what the book's doing. So negative 16t squared plus 64. Let's put that in our calculator. I'll clear these other equations out. So negative 16t squared plus 64. Okay, I'm going to make a table. And you notice 0 seconds, the egg is 64 feet in the air. After 1 second, it's 48 feet in the air. After 2 seconds, it's 0 feet in the air. It means it's hit the ground. So the answer is 2 seconds. And you can see that represented here. Okay? Same thing, and the egg hits the ground after 2 seconds. Okay? Suppose the initial height is adjusted by k feet. How will this affect part A? So in other words, let's just pick a number. Pretend k was 10 feet. If we added 10 feet to the height of the egg, how's that going to affect the answer? Well, if I move the egg higher into the air, it's going to take more time for the egg to hit the ground. However, if I subtract, let's say I drop the egg down, I go down to this floor, and I'm only 54 feet in the air. If I go down 10 feet, it's going to take less time for the egg to hit the ground. Okay? So that's what they're asking here. That's just telling me that I'm taking my graph, and remember, if I add something, that's C value. Okay? If I add something, it's going to move my vertex up the graph. If I take something away, it'll move it down the graph, and the rest of the graph will adjust accordingly. I'm going to pause the video here. If you have any questions, make sure you ask in class.